Have you ever stood in a supermarket, picked up a loaf of bread, and thought about how the wheat inside it actually got there? Most people have a vague image: fields, tractors, farmers. But the real answer involves a single machine so large, so complex, and so precisely engineered that without it, the food systems of entire countries would collapse within weeks. Today, we are going to break down exactly how that machine works. And I promise, by the end of this, you will never walk past a grain product on a supermarket shelf without understanding the extraordinary chain of events that put it there. The machine is called a combine harvester, and the name tells you almost everything about what makes it revolutionary. Before it existed, harvesting grain required 3 completely separate operations carried out by different teams using different tools at different times. First, the crop had to be cut. Then it had to be threshed, meaning the grain had to be beaten free from the stalks and husks. Then it had to be cleaned, separating the grain from the chaff and debris. Each of those operations took days, sometimes weeks, and required enormous numbers of people working in coordinated teams across the fields. The combine harvester does all 3 of those things simultaneously. In a single continuous pass across the field, it cuts the crop, separates the grain, cleans it, and deposits the finished product into a holding tank ready for transport. What once required the labor of hundreds of people over weeks can now be accomplished by a single operator in a matter of hours. That compression of time and labor is not just an agricultural achievement. It is one of the foundations of the modern food supply. To understand what is happening inside the machine, you have to follow the crop from the moment it meets the header at the front. The header is the wide cutting platform that stretches across the front of the machine. On a large modern combine, that header can be 12 meters wide or more, sweeping a vast swathe of crop with every pass. Inside the header, a rotating reel pushes the standing crop toward the cutting bar, a row of reciprocating blades that slice through the stems close to the ground. The cut material is then gathered by an auger, a large rotating spiral that consolidates the crop from across the full width of the header and feeds it toward the center where it enters the main body of the machine. What happens next is where the real engineering begins. The crop enters the threshing drum, a large rotating cylinder covered with raised bars or rasp bars. As the crop passes between the drum and a fixed concave grate beneath it, the mechanical action of the rotating drum beats the grain free from the heads. The grain, being small and dense, falls through the gaps in the concave grate and drops onto a series of shaking sieves below. The straw, being long and light, is carried over the drum and moves toward the rear of the machine. But not all the grain is separated at the threshing drum. Some of it remains tangled in the straw. This is where the separation system takes over. In older designs, this was done by a system of straw walkers, long oscillating frames that shake the straw vigorously to dislodge the remaining grain. In modern high-performance machines, it is done by rotary separation systems, where the straw is wrapped around 1 or 2 large rotating cylinders, and the centrifugal action throws the remaining grain outward through perforated walls. The grain falls down onto the cleaning system below. The straw is expelled from the rear of the machine onto the field. Now the grain has been separated from the straw, but it's still mixed with chaff, small pieces of husk, dust, and broken plant material. This is where cleaning happens. The grain falls onto a system of oscillating sieves, and a powerful fan beneath them blows a continuous stream of air upward through the falling material. The heavier grain falls through the sieves. The lighter chaff and debris is blown backward and out of the rear of the machine. What remains is clean grain, which is then elevated by a grain tank auger up into the holding tank on top of the machine. That holding tank can hold many tons of clean grain. When it is full, the operator extends a folding unloading auger from the side of the machine and transfers the grain into a trailer running alongside in the field. That trailer then takes the grain to a storage facility or directly to a truck for onward transport. The combine never needs to stop. The entire operation is continuous. The scale of what a modern combine harvester can achieve in a single day is genuinely difficult to comprehend. A high-performance machine operating in good conditions can harvest upward of 50 hectares in a single day. To put that in context, 50 hectares is roughly the equivalent of 70 international football pitches. A field that size, planted with wheat at typical yields, might produce enough grain to make 200,000 loaves of bread. One machine, one operator, one day. But here's something that most people have never considered. The combine harvester is not operating alone. It is the centerpiece of a precisely coordinated logistics system that begins months before harvest and continues long after the machine has left the field. The grain that comes off the combine has to be transported, dried if its moisture content is too high, stored in conditions that prevent spoilage, and eventually moved to processing facilities where it is milled, malted, or otherwise transformed into the food and drink products that reach consumers. Moisture is one of the most critical variables in the entire chain. Grain harvested with too high a moisture content will not store safely. It will heat, develop mold, and become worthless within weeks. Modern combines are equipped with sensors that measure the moisture content of the grain in real time as it passes through the machine. That data is used by the operator to decide whether the crop is ready to harvest, and is also fed into farm management systems that track yield and quality across every part of the field. Those management systems are increasingly sophisticated. Modern combines are fitted with GPS receivers and yield mapping technology that records exactly how much grain was harvested from every square meter of the field. That data, accumulated over multiple seasons, tells the farmer which parts of the field are most productive, which might benefit from different seed varieties or fertilizer rates, and where drainage or soil improvement work might be needed. The combine has become not just a harvesting tool, but a data collection platform that informs the management of the farm for years to come. The engines powering these machines are in a class of their own. A large combine harvester is driven by a diesel engine producing upward of 500 horsepower. That power is needed not just to propel the machine across the field, but to drive all of the internal mechanical systems simultaneously. The threshing drum, the separation system, the cleaning fans, the augers, the header, and the unloading system are all drawing power from the same engine at the same time. Managing that power demand efficiently, particularly in heavy or damp crop conditions where the machine is under maximum load, is one of the key skills of an experienced operator. And that operator role, while it has changed dramatically with the introduction of automation and guidance systems, remains critical. Modern combines can steer themselves along pre-programmed guidance lines using GPS. They can automatically adjust their internal settings in response to changing crop conditions. But the decisions about when to start, when to stop, how to manage the headlands at the edges of the field, and how to respond to unexpected problems still require human judgment. The machine amplifies human capability. It does not replace human understanding. There is one dimension of the combine harvester story that rarely gets told, and it is perhaps the most important of all. The machine did not just change how grain is harvested, it fundamentally changed the structure of rural society. Before mechanized harvesting, the grain harvest was one of the great communal events of the agricultural year. Entire communities came together. Neighboring farms sent workers to help each other. Temporary laborers traveled from region to region following the harvest as it moved across the country with the changing seasons. The harvest was not just an economic event, it was a social one, woven into the rhythm of rural life in ways that shaped communities for generations. The combine harvester ended all of that. Not immediately and not without resistance, but decisively. As machines replaced the need for large harvest gangs, the demand for seasonal agricultural labor collapsed. Rural populations that had been sustained by the labor requirements of traditional farming found that the land no longer needed them in the same numbers. The migration from rural areas to towns and cities that characterized the 20th century in almost every industrialized country was accelerated in part by the productivity of machines like the combine harvester. That is not a criticism of the technology. It is simply an honest account of what it changed. The economic transformation was equally profound. Before mechanization, the cost of harvesting was dominated by labor. Farmers had to pay and feed large teams of workers for weeks at a time. The combine shifted that cost structure entirely. The dominant cost became the machine itself, its fuel, and its maintenance. A farmer who could afford a combine harvester, or who could share one with neighbors through a machinery ring or cooperative arrangement, could now farm land areas that would have been impossible to harvest manually within the narrow window that the weather allowed. Farm sizes grew. Smaller operations that could not justify the investment in machinery either merged with larger neighbors or disappeared entirely. The consolidation of agricultural land into larger and larger holdings that has characterized farming in Europe and North America over the past 70 years is inseparable from the economics of mechanized harvesting. But here is something that brings the story right up to the present day. The combine harvester is currently undergoing the most significant transformation in its history since the shift from horse-drawn to engine-powered machines. Fully autonomous combines capable of operating without a human operator in the cab are already being tested in commercial conditions by manufacturers, including John Deere. The machine navigates using a combination of GPS guidance, LiDAR sensors, and camera systems that monitor the crop conditions in real time. When the grain tank is full, the machine signals automatically to a chase vehicle which pulls alongside to receive the unloaded grain. When a blockage occurs or a mechanical problem is detected, the machine stops and alerts a remote operator who can assess the situation and intervene if necessary. The implications of full autonomy are significant. A single farm manager could theoretically oversee multiple machines operating simultaneously across different fields, intervening remotely only when needed. The labor requirement for the harvest operation would fall further still. The precision of the operation would increase because an autonomous machine does not get tired, does not make the small errors of judgment that accumulate over a long day in the cab, and can operate through the night when conditions allow. The window of good harvesting weather, always the most critical constraint on the operation, could be exploited far more completely than it can today. Whether that future is desirable in every respect is a question that goes beyond engineering. But the direction of travel is clear. The machine that transformed the harvest once is in the process of transforming it again. What all of this adds up to is something that goes far beyond a piece of agricultural equipment. The combine harvester is one of the most consequential machines ever built. In countries where it is widely used, a tiny fraction of the population is now capable of producing enough grain to feed everyone else. In the United Kingdom, for example, fewer than 2% of the working population is employed in agriculture, yet the country produces the majority of its own wheat, barley, and oilseed requirements. That is only possible because of the extraordinary productivity that machines like the combine harvester make possible. That is what I find genuinely remarkable about this. The machine that feeds entire countries does its work in a matter of weeks each year, in fields that most people drive past without a second glance, operated by people whose names nobody knows. And yet the chain it sets in motion, from seed to field to machine to mill to shelf, is one of the most intricate and essential systems in human civilization. Now here is something worth thinking about. If one machine can harvest 50 hectares in a day, what happens when that machine breaks down in the middle of harvest season, when every hour of good weather counts and the window for cutting the crop is measured in days? The answer involves a global network of parts, technicians, and logistics that most people have never heard of. That story is already waiting for you in another video.